Our equation is y equals 3x squared over x squared minus 4. Okay, for the first step, now we have to find the asymptotes. And to find the vertical asymptotes, we set the bottom of the equation equal to 0. So we get x equals 2 and negative 2. And for the vertical asymptotes, since our powers are the same, we put the coefficients equal each other. So we have y equals 3.
Okay, next you use the asymptotes to find the domain. So it's going to be negative infinity to negative 2 because that's the leftmost asymptote. Union, where it joins up again, negative 2 to 2. And then it breaks at the asymptote. And the last union to positive infinity.
Okay, so for a third step, we have to find the intercepts, which we do by setting the top equal to 0. And when we do that, we get x squared equals 0. So we have an x at 0. And when we plug that back into the original equation, we find we get an intercept at 0, 0.
Okay, so next to check symmetry, we plugged in x as 1 and x as negative 1. So when x was 1, it was equal to 3 over 1 minus 4, which ends up being negative 1. When it was negative 1, it was y equals 3 over 1 minus 4, which is once again negative 1. And because these two are equal, it is even.
All right, for the next step, we have to find where the graph is increasing and decreasing. So to do this, we have to take the derivative of the original equation. And then from this, we can simplify.
Now that we have our derivative, we're going to plug numbers in between our asymptote at negative 2, our intercept in the middle at 0, and our other asymptote at 2 to see where our graph is increasing and decreasing. So we're going to plug negative 3 into the derivative. So it's going to be positive on top and also positive on the bottom, so overall positive. And then we're going to plug negative 1 in to our derivative, and it's going to be positive on top and once again positive on the bottom, which results in a positive. And then we're going to plug 1 into our derivative, which is negative on the top and ends up being positive on the bottom, which is an overall negative. And then we're going to plug, finally, 3 into our derivative, which is, once again, negative on the top and then positive on the bottom, so overall a negative. So this shows us that it's increasing from negative infinity to negative 0, increasing from negative 0 to 0, and decreasing from 0 to 2 and to positive infinity.
So now that we know where our graph is increasing and decreasing, we could see at 0, the graph is increasing and then decreases again, leading us to believe that there's a max at 0, and since the graph doesn't change again, there's no minimum.
So for the concavity, we're going to find the second derivative. So then we can cross out 1 here, this one, and make this 3. We can simplify this down ultimately to negative 24 times x to the second plus 4 plus 4x squared all over x squared minus 4 to the third. So now we're going to take the top part and set it equal to 0 to find the possible inflection points. So it's going to be 5x squared plus 4 equals 0, and it's going to end up equaling 5 equals the square root of negative 4 over 5, which is imaginary, so this can't be the inflection point. So we have to find it some way else. So we set up one of these, but just with the asymptotes because they're the only things that would change concavity here. And we're going to plug in negative 3 to the second derivative. And there we're going to get a positive. We're going to plug in 0 to the second derivative and get a negative. And finally, we're going to plug in positive 3. And there we're going to get a positive. So this shows where the concavity changes. So as it approaches our asymptote at negative 2, it's going to be concave up. As it moves between negative 2 and 2, it's going to be concave down. And finally, after the asymptote at 2, it's going to be concave up again.
So now that we have the information, we can actually graph it. So we know that there's an intercept at 0, 0, and we know that there are asymptotes at negative 2, 2, and 3. Now, before negative 2, we know that it is concave up, and the graph is increasing, so it'll look something like this. And in between negative 2 and 2, we know it's concave down, and it goes from increasing to decreasing at 0, so it looks something like this. And then after 2, it's also concave up and decreasing, so it'll look something like this.